we discuss the solution of a problem that has appeared in CSIR-UGC National Eligibility Test. The problem is on the rank of a matrix, and it has appeared in CSIR-UGC NET examination held on 26th November 2020. It is from the section C, and it carries 4.75 marks. The problem is, let A be an n by n matrix such that the first three rows of A are linearly independent and the first five columns of A are linearly independent. Which of the following statements are true? Option 1. A has at least 5 linearly independent rows. Option 2. 3 is less than or equal to rank of A less than or equal to 5. Option 3. Rank of A greater than or equal to 5. Option 4. Rank of A square is greater than or equal to 5. Before discussing the solution of the problem, let us recall the following definitions. The maximum number of linearly independent rows of a matrix A is called the row rank of A, and it is denoted by row suffix R of capital A. The maximum number of linearly independent columns of a matrix A is called the column rank of A, and it is denoted by row suffix C of the matrix A. And it is a well-known result we have. The row rank and the column rank of a matrix are equal. That is, row rank of A is equal to the column rank of A. The common value of the row rank and the column rank of a matrix is called the rank of A, and it is denoted by row of A. Let's get into the problem. This is the problem. The solution is, we have a square matrix capital A of order n. It is given the first three rows of A are linearly independent. This implies the row rank of A is greater than or equal to 3. It will be at least 3. Given the first 5 columns of A are linearly independent, this implies the column rank of A is greater than or equal to 5. It is well known that the rank of A is equal to the common value of row rank of A and column rank of A. Therefore, row rank of A greater than or equal to 3 and the column rank of A greater than or equal to 5 will imply rank of A greater than or equal to 3 and the rank of A greater than or equal to 5. So, let us look at the option 3. The option 3 is rank of A greater than or equal to 5. So, rank of A greater than or equal to 5 we also have. So, the option 3 is true. And in the option 2, the rank of A is less than or equal to 5, but we have the rank of A greater than or equal to 5. Therefore, the option 2 is not true. Rank of A greater than or equal to 5 will imply A has at least 5 linearly independent rows. So, therefore, the option 1 is true. In option 1, A has at least 5 linearly independent rows. So, we got that. Therefore, the option 1 is true. We continue in the next slide. We will construct a matrix capital A of order n as follows. This construction is very crucial. Let 5 less than or equal to m less than n. Let B is equal to the set consisting of E1, E2, En be the standard basis of R power n. Define a linear transformation T from R power n to R power n by T of EI, the action of the transformation on EI is EI for I is equal to 1, 2, 3 up to m minus 1. And the action of T on EM is EM plus 1. And the action of the remaining EJs, T of EJ will be 0 for J is equal to m plus 1, m plus 2 up to n. So this is the definition. Now we can write the matrix of T with respect to B. Let A is equal to the matrix of T with respect to the standard basis B is equal to the matrix with respect to the standard basis B is equal to and T of EI is EI 1 less than or equal to I less than or equal to m minus 1. So therefore we write EI as a linear combination of E1, E2, E3, so on and so forth. That means you will get E1 only. That is the column vector is E1. So EI, we will write it as the column vector in the ith position. So if you take E1, T of E1 is E1. So therefore we write the E1 as a column vector of the matrix, E2 as a column vector of the matrix, EM minus 1 up to EM minus 1 the column vector of A. But now in the mth column T of EM is EM plus 1. So in the mth column we will have EM plus 1 and the remaining column vectors are 0. So we have E1, E2, EM minus 1, EM plus 1. So up to that we have. So they note that E1, E2, EM plus 1 are the columns of A and the 0 with bold faced is the column vector with every component 0. So clearly the rank of A will be E1, E2, EM minus 1 up to M minus 1, M minus 1 and the mth position. So these are M linearly independent column vectors. Therefore rank of A is equal to M, which is we have taken by supposition M greater than or equal to 5. Now we continue. Now we will talk about what will be the matrix A square. So we take T and talk about the T square. So T square of EI is T of TEI and T of EI is EI. So T of EI and T of EI is equal to EI for I is equal to 1 to up to M minus 1. So and T square of EM is T of EM. T of EM is EM plus 1. T of EM plus 1. Here T of EM plus 1 is 0. And T square of EJ will be T of EJ and that will be equal to T of 0 that is equal to 0 for J is equal to M plus 1 to N. So the A square, the matrix of T square with respect to B will be, so for I is equal to 1, 2, 3 up to M minus 1, the image under T square is EI only. So therefore the column vector E1, the column vector E2, the column vector EM minus 1. In the mth position we got 0, the column vector 0. From there onwards everybody is 0. So these are M minus 1 linearly independent column vectors. So therefore rank of A square is equal to M minus 1. M greater than or equal to 5, therefore M minus 1 greater than or equal to 4. But your option 4 says rank of A square greater than or equal to 5, which is not true. So therefore the option 4 is not true. So our final answer is the options 1 and 3 are true. So that is the discussion of the problem that has been given in a CSIR-UGC NET examination. And it is based on the rank of a matrix. I hope that you have understood and appreciated the solution. I wish you all the best. Thank you.